All right. Now we're going to talk about the algebra of functions. When we say the algebra, what we're talking about are these binary operators. The reason they're called binary operators is because you need a number in front and you need a number in back. So you need two numbers to make it do anything. So let's look at the different types. So let's look at the sum. The sum rule of functions. We're of course assuming that f and g are functions. So what does it mean to be a function? If f and g are functions, why is that such an important statement?
Well, function means that each x point corresponds to y, right?
Yes.
So it's a one-to-one.
It's one-to-one. And preferably continuous. And since it's one-to-one, it should have a slope at every point. So the sum rule says this. F plus g is the same thing as f of x plus g of x. Notice the only operation we have is plus. An example of this would be oh, yeah, I can't use that one. Not yet. If we have this. What that means, I can have 4 times x plus 5 times x. It's also the distributivity rule. The difference rule it just deals with f minus g. So that could be f of x minus g of x. I guess I can show you all with the letters and graphs and everything. So if we had, as I was going to put in there earlier, 5x squared plus 3x minus 1. What I'm saying here is this is my f function. This is my g function. So f of x would be 5x squared plus 3x minus 1. Because once I define a value for x, I could plug them in there. Then we have the product rule. What does product mean?
The result of multiplication.
The result, yeah. The solution, the result, yeah, right. So f times g can be f of x times g of x. And the last one is the quotient rule. So let's separate these. As long as the denominator does not equal 0. There really should be one more in there. The constant multiple. We'll say that a is a number. What we did last class, when we first introduced the library of functions, we talked about the domains and ranges. What about the domains of these functions?
The domain is always the x values.
Yes, but now we have two functions in one time. Because remember, last time we looked at, if I had x squared, that's a quadratic equation. What is this domain? But now I have a combination of two functions. Now I have a combination of two of them. The domain of the algebra of functions I hope this this way. It's where they overlap is the common values of both functions. In other words, it's where they overlap. Plus, for the quotient rule, it omits where the denominator equals 0. Okay, so think about that now. What that means is if we have a combination of two or more functions, what we have to look is each one of those functions separately, find the domains, and see where they overlap.
So if they don't overlap, what's the domain then?
Doesn't exist
Oh, okay.
because we can't combine them if they don't overlap.
Right.
Because yeah, you two functions can only be combined is if they exist, because if one of them had, let's say, if one of them only accepted negative numbers, the other one only accepted positive numbers, then you couldn't put numbers in there because you can't put them in both functions. Example 1. Given that f of x is equal to x plus 1 and g of x equals x plus 3, find these. F plus g of x. I'll make just 4 of these. B, f plus g of 6. F plus g of negative 4. And I'm going to throw in there this last one. The domain of f plus g. So how do we do this? Well, we have to first is remember, what's the rule say about the sum of two functions? It's f of x plus g of x. So f of x is x plus 1. Since we have the addition symbol, it's plus the square root of x plus 3, which is g of x. And there you have it. You can't combine like terms. Typically, whenever you put something in there, you put parentheses around it first. But since it's the leading term, I don't have to worry about it. Typically, whenever I substitute in place of x, typically you do this first. But since it's the leading term, it's the first term in the sequence, I don't need the parentheses. There's no coefficient in front of it. Okay, now B. What it's telling us is f of 6 plus g of 6. Now, what is it exactly telling us? It's telling us we can do it two ways. One, we can combine the functions together first and then plug in the 6. In other words, I can have x plus 1 plus x plus 3, and then plug in 6 anywhere I see an x. So this 6 plus 1 is 7. 6 plus 3 is 9. So 7 plus 3 equals 10. Or this tells us we can find the individual values first and then add the answers together. So what is f of 6? F of 6 is 6 plus 1, which is 7, plus g of 6 is 6 square root of 6 plus 3, square root of 9, which is 3. And then add them together. Which side's easier?
The right side.
The right side. Yeah. Is it always going to be the case? Not really, because sometimes you can have functions when you add them together, it can cancel out things. So it can simplify the whole process. Okay, let's look at C. So this is telling us f of -4 plus g of -4. So what is f of -4?
So the point of the negative one.
Right, which is,
Negative.
so that becomes -3. G of -4 is -4 plus 3.
So that in turn becomes -1, which that's
Does not exist. So the solution does not exist. Well, let's see why not. What's the domain of f of x? What kind of function is it?
it's a slope intercept form.
So what kind of equation is it? From the library of functions we did last time. Nope. It has to be one of those 12s we talked about last time. You won't find it in there because we did it on a piece of paper last time in your notes. And
Is an absolute value function?
no. Speaking of that, here you guys go. Here are the sheets I promised you from last time. You need to fill them in.
I'm gonna say linear function.
Yep. Why is it a linear function?
Because that X is telling us, that it's just one line.
There's only, well, yeah, it has no special operations. It has no exponent, no, it's not in the bottom. So it's a linear equation. Well, think about it this way. We talk about y equals mx plus b. Does that satisfy the y equals mx plus b? Yes. Because the m is whatever is in front of the x. The slope is 1 and the y-intercept is 1. So what's the domain of a linear equation?
All real numbers.
Negative infinity to positive infinity, right? All real numbers. Now let's look at the domain of g of x. Oh, x plus 3. What do we know about this? What kind of question is this? What kind of equation is this? What's that? Nope.
It's radical.
It's a radical. It's a square root because there's no number in there. So what's the domain for the square root thingy? Yes. So the smallest this number inside here can equal is 0. So we solve for x. Since now, if x is -3, that makes it 0 inside there. So our domain is from -3 to infinity. I could put -3. I could put 0 in there. I could put 5 in there. So it's from -3 to infinity. So looking at both of these, here's the function f, g, and here's f plus g. F goes from negative infinity to positive infinity, so it's everything. G goes from -3 to infinity. So where do they overlap? From -3 to infinity. So those are the only numbers we can use. Those are the only numbers, that's our domain of our function. So is -4 inside the domain?
No.
No, -4 is outside. That's why it tells us we can't use it, because -4 is not in our domain.
So the way that we would write it out is domain is F plus G, or is domain -3 to?
The domain is -3 to infinity. But we're talking about there, it's the domain of F plus G. We have to first find the domain of F, find the domain of G, and see where they overlap. Let's look at example 2. Given f of x equals x squared minus 4, g of x equals x plus 2. Find the following. A, the domain of f plus g, the domain of, what's the domain here? Domain of f minus g, domain of f and g, the domain of f over g. So how do we begin?
You'd be solving F and then solving G.
Yeah, so what's the domain of f?
Honestly, I get a little bit stuck when I don't have it.
Look at the thing we did last time. Look at the library of functions we did last time. I gave you the blank one, but we did it in class last time. It should be in your notes. What kind of function is f? Quadratic. So the quadratic function, the domain is what? Negative infinity to positive infinity. It's all real numbers, right? All this -4 does is it moves it down, moves the graph 4 spaces down, because it's not inside the x. Now the domain of g, so this is from negative infinity to positive infinity. The domain of g is what? Yeah, because it's a linear equation. So f is quadratic. G is linear. So the domain of f plus g is all real numbers. It goes from negative infinity to positive infinity. So the domain is from negative infinity to positive infinity. How about the f minus g?
So. In this F and G, they don't change, so would the domains not be negative infinity, positive infinity, if all we're doing is?
Yep, that's what's going to be in this one. Because the functions themselves, as you said, they don't change. So the third one, C, is going to be what? the domain is negative infinity to positive infinity. And then the last one, what's the domain? Nope. Because what we have here is this. We have x squared minus 4, x plus 2.
So if x is -2, though, it could be 0, which means that the domain does not exist. Right?
Well, yeah, because you set the bottom equal to 0. So x cannot equal -2. So our domain is from negative infinity to -2, -2 to positive infinity. Even though our graph, because this top one is a difference of two squares. It's x minus 2, x plus 2, which is what we did in chapter. We'll talk about a little bit about chapter 1. We'll go further into that next chapter. X plus 2's cancel. So the equation is going to be the graph of x minus 2. But at 2, we have a 0 there. An open spot. Because it's a hole. The hole happens what would this function look like? If we did the f times g. Let's do all of them. F plus g would be x squared minus 4 plus x plus 2. I don't need the leading parenthesis. And since there's nothing in front of the second, I can just drop both of those. Combine like terms. X, the next big one is x. -4 plus 2 is -2. So that's what f plus g would look like. Let's look at f minus g. So we have f of x, which is x squared minus 4, minus the x plus 2, which is, this is f of x, this is g of x. I don't need the first parenthesis since there's nothing in front of there. But the second parenthesis has a minus in front of it, a -1 actually. So I distribute. Negative times positive is negative. Negative times positive is negative. Combine like terms. So the biggest x first, then the next x, then the constants. -6. F times g. X squared minus 4 times x plus 2. How do we multiply these? Distributivity. Everything in this one multiplies to everything in this one. So let's start with this one. X squared times x gives us how many x's? 3. There's 2 there, there's 1 there, now I have 3. They're both positive. x squared times 2 is positive 2x squared. That's it for that one. Next, we have negative times positive is negative. 4 times x is 4x. Negative times positive, 4 times 2 is 8. Can't combine anything, so there I have it. And we already did this one. F over G, so it's x squared minus 4, x plus 2. Whenever you have a degree higher than 1, you factor it out if possible. So it's x plus 2, x minus 2. And we'll go, don't worry about that if you don't understand what's happening there. We'll go over that in detail very shortly. Next chapter. The x plus 2's cancel, so our final answer is this. Where x cannot equal negative 2. That's just A of that question, of example 2. That's just A. Well, actually, we just did them all. This is part B, part C, part D, part E. The only thing left we have to do is part F. F says, what is that? Remember, f of x equals x squared minus 4. G of x equals x plus 2. So what this means is g of x times g of x, which is x plus 2 times x plus 2. What's the domain? Since they're both the same, what's the domain of G? Yeah, because it's a linear equation, we know it's all real numbers. So this one would be x times x is x squared. Positive times positive is positive. X times 2 is 2x. Positive times positive is positive. 2 times x is 2x. Positive, positive. 2 times 2 is 4. Combine like, whenever you get rid of parentheses, first thing you do is combine like terms. We have those. 2x plus 2x is 4x. It's 4. And there's your answer. So far, so good. All right, so that's so whenever you have two functions or more functions, find the domains of each one of them separately, and then by overlapping them, you can see what the final answer is going to be. I'm going to say plural, slopes. Up until now, what kind of slopes have we been talking about? What kind of functions are we dealing with? We calculated slopes to what kind of functions?
Oh.
Linear equations. How do we find the slope of a linear equation? Well, what if I gave you this? What's the slope of that equation?
Three.
By itself.
Nope, nope. Remember what we have to put in this formula. Whenever I give you an equation, a linear equation, you have to solve for y because whatever is in front of the x. You're right. You're right. By saying 3, because what you've talked about so far is whatever is in front of the x is your slope, but that's only if y is by itself. So we have to solve for y, right? Let's solve for y, so it looks like this. So we subtract 3x from both sides. We have negative 3x, negative 10. What's the next step? Nope, this is not like terms. This is x, that's not x. Apples and oranges.
Divided by 5.
Divide each term by 5 now. So now we have y by itself equals negative 3 over 5x minus 10 over 5 is 2. So the slope is no, negative 3 over 5. So what's the line going to look like?
Move a diagonal that's goes 3 up and 5 to. Straight line.
The negative either belongs in front of the equation or on top. The bottom number is always positive. Because when you subtract two numbers, for example, if I had 3 over 5 minus 7 over 5, the rule says if you have a common denominator, put that down. Now, the only way this could be negative since it's negative, 7 minus 3 is 4. The negative belongs to the top or in front. So since the slope is negative, it'll be a decreasing slope. It's going down. And that's what we talked about last class. Decreasing is as x goes forward, as x1 is less than x2, y1 is greater than y2. It's a decreasing. So as x1 is less than x2, y1 is greater than y2. That's decreasing. But there's another way you can do this. This is what we talked about last time, increasing, decreasing. We can use slope face. It sounds Mickey Mouse, but trust me, I've had seniors and graduate students use this. So you have to think about it. If it goes up from left to right, is it positive or negative slope? It's a positive slope. If it goes down from left to right, it's a negative slope. If it goes up and down, it's what kind of slope? Undefined. If it's horizontal, it's 0. So there's slope face.
I like what you did. I like what you did there.
It sounds Mickey Mouse, but it works.
Does work.
You'll never forget this face. It looks like he got beat up though. His just one eye's open, one eye's closed.
Yeah.
And he's not happy. But slope face, it's again, people just when they take tests on this chapter, they create the slope, the face, and then now I have to think about it. If I give you a negative slope, you know it's looking like this. It's going down. But what equation did we use to find a slope of a line? It was m equals, do you remember this formula? Excellent, very good. So that's given 2 points, and it's a slope of it. X1, Y1, X2, Y2. But as we saw last time, that's only one of 12 different types of graphs we have. What about if I gave you this? What function is that? See, now your notes, get a bunch of highlighters, different colors. So you see, if it's an example, highlight just the first thing as yellow or red and make them different. Examples, definitions.
I've done that for other chapters, but I haven't done that. for the
Yeah, because it'll make it much easier when you flip through it.
Yeah, it's a quadratic.
Yes, it's y equals x squared. So the problem with curves is we can't find the slope with this equation. If we were to try to find a slope between 2 points, is that the slope of the curve? No, that's simply the relationship between those 2 points. This is called a secant line. A secant line cuts a curve in 2 points. It's a straight line that cuts a graph at 2 points. So what is the problem here? The problem is the slope of a curve can only happen at 1 point. The slope of a curve can only occur at 1 point. Is it the same at every point on the curve?
No,
Why not?
well, if I'm looking at it, it's because the curve moves out in two different ways.
Which means,
That's because it means positive on one side, negative on the other.
very good. On this side, it's a positive slope. On this other side, it's a negative slope. And what happens in the middle? What happens at the vertex?
Horizontal.
It's a horizontal. So we have a negative slope here, we have a positive slope here, and we have a zero slope at the vertex. So what we have to do, we have our x1, our x2, and then we have our y1, and we have our y2. Let's say I want to know the slope of the curve at point A, which is down at the first point. I can still use this concept, but I have to move these points closer. So now as I move these points closer, I'm getting a better picture of what my slope is. And then if I get even closer, here's x4. I can find the slope of this line. And even closer. So what's happening here? We call the distance between these x points, we call that h. What does h represent? Well, if I start off at point x1 and I add h to it, where do I get to? I get to x2. Yeah. If h is this long and x1 starts here, if I add them together, I end up here. Remember our formula for a slope, though. Our formula for a slope is y2 minus y1, x2 minus x1. X2 minus, so if I subtract x1 from both of these, I get h. H is x2 minus x1. So that's what h is. The distance between x1 and x2 is h. But now how does that change these? How does that change those? Well, this one is f of x2 minus f of x1. Because remember, what we're trying to get to is we're trying to find the slope of the curve at x1. So we need to have an equation here that only has x1 as a variable. How can we do that with what we know so far? H is a distance between there. We have f of x1 over here already. So what is f of x2? How can we rewrite x2? X2 is x1 plus h. So now all we need is one x value because it's the same x value in both of those. So f of x plus h minus f of x over h. This is what is called the difference quotient. It's the slope of any curve at any x value. It's the slope of the curve. Well, let's go even further than that. It's the slope of the line tangent to the curve at any x. So the difference quotient is actually this. It's the slope of the line tangent to the curve at any x. We used a new word here, tangent. What is that line called? Secant line. because it crosses at 2 points. The tangent line only touches the curve at 1 point. So kind of like skipping a rock on a pond. When you skip it, it becomes tangent to it. It just bounces off again. So what we found here is we found the slope of that line right there. But now think about it. Since we found the slope of the line tangent to the curve at 1 point, now we have a slope and we have the point in which it touches. So what can we do with that? We have the slope and a point. We can find the equation of the line tangent. We can find this equation. That's what we did in chapter 1. We have this. We can find y equals mx plus b of the tangent line. Right. Let's look at some examples here using the difference quotient. Example 3. F of x equals 2x minus 3. Find the function f. Now, given the function f, find and simplify the difference quotient. Remember, the difference quotient is f of x plus h minus f of x over h. That's the difference quotient. Remember, whenever you do anything in math, when you read the question, put down what you know. I gave you the function. I said, find the difference quotient. Well, what's the formula for it? Looking at the formula, what do we need? H is just any h. Okay, so h, okay. We have f of x right here. Do we have f of x plus h? So we have to find. So first step. Find f of x plus h. And that's super easy. Anywhere you see an x in your equation, just change it to x plus h and put it in parentheses. Second step, plug f x plus h and f of x into the formula. And simplify. Notice I didn't say solve because we're not solving for anything yet. We're just simplifying the equation. So we know my difference quotient is f of x plus h minus f of x over h. So f of x plus h is 2x plus h minus 3 minus 2x minus 3. Notice how I put them in parentheses. I put them in parentheses so I can separate them. The reason I do that is because I have to work both of those, simplify both of those separately. So what can I do inside the first parenthesis?
Distributivity.
Right, yes, exactly. Now, since I can't do anything inside there, I get rid of the parenthesis, right?
This one didn't work.
So all I did was get rid of the first parenthesis inside there. Can I combine any like terms? Inside that first parenthesis? No. Can I combine any like terms in there? No. So I got to get rid of the parentheses. The first parenthesis doesn't have anything in front of it, so I can just drop the parentheses. And the second parenthesis, since it has a negative in front, I change all the signs inside there. So it used to be positive 2x, now it's negative 2x. Used to be negative 3, now it's positive 3. Here's an important point. Everything after this minus sign here, everything, once you get rid of the parentheses, all these numbers here have to disappear. They have to cancel out. The negative 2x and then 2x. The positive 3, negative 3. Everything after the minus, after this minus sign, when you get rid of it, everything there has to disappear. If it doesn't, you did something wrong. So now I have 2h over h. Cancel the h's. So my slope is 2. How do we know that's right? Nope. Look at our original function. What kind of equation is it? It's y equals mx plus b. It's linear. So whatever's in front of the x is your what? Yep. So since they're the same number, we did it correctly. But yeah, that only works with linears. So to practice your skills, that's what you want to do. Now, the next two examples will show you the work involved for higher order ones. Example 4. F of x is equal to 1 over x. Find the slope using the difference quotient. So since it says find the slope of using the difference quotient, I put down what I know so far. The formula. F of x plus h minus f of x over h. Do I have everything I need? What am I missing? H is any value. So that's simply the distance between x1 and x2. So h doesn't have a value. Do we know f of x? Do we know f of x plus h? No. So we have to find f of x plus h. So anywhere you see an x, put it in parentheses, x plus h. Now we have everything we need for the formula. F of x plus h is 1 over x plus h minus 1 over x. All that over h. Because we have a compound fraction here, work the top by itself and work the bottom by itself. What do we do with the top? How do we work on that one? No, this is an equation. This x plus h has to stay together. We're subtracting two fractions. What's the rule about subtracting fractions?
LCD.
You have to have a common denominator. This one has an x plus h. Does this one? No. So it needs an x plus h. This other one has an x. Does this one? That's not the same x because this is x plus h. So it needs an x over x. Yeah, so since this is in parentheses, it's not the same as that x. So we have a common denominator on top. We have x plus h. And on top, 1 times x minus x plus h over h. Okay, we can't do anything with a numerator up on top. The denominator, I mean. We can't do anything with the x. We can't do anything inside the parenthesis here, so we have to get rid of the parentheses. So we distribute. So the x's cancel. X minus 8 cancel. X plus h. And all we have left on top is negative h. And on the very bottom, h. We have a fraction over a fraction. Because this is a fraction, that's a fraction. Whenever you have a fraction over a fraction, take the top number, leave it alone. Just put A over B. Flip the bottom one and multiply it to the top. So I take the reciprocal, I flip those and multiply it. So I have negative h x 8x plus h times 1 over h. Can anything cancel top and bottom? The rule of multiplication of fractions, never multiply first. Reduce first before you multiply. Can anything on top cancel with anything on the bottom? The h. So what do we have left on top? Negative 1, because h goes in h one time. And on the bottom, we have x plus h, which is my slope. Now, what this tells us is this. Remember, what does h represent? Is the distance between x1 and x2. And since it's a curve, how far should they be apart? When we have a curve, we can only use 1 point. So the h has to be what? 0. x1 and x2 better be the same. Because if we're going to find the slope of a curve, we only want 1 point. So x1's here, x2's there. So this h gets small, closer and closer and closer and closer and closer. Eventually, they become the same point. H becomes 0. x1 equals x2. So we're saying here, as h gets closer to 0, our equation becomes x times x. And that's our equation of our slope. So this is our slope equation. So for any x you give me, that's the equation of the slope of that curve. Example 5. Let's say f of x equals 2x squared minus x minus 3. What kind of equation is this? Yep, because the degree is 2. It's quadratic. So we know the graph is going to look something like this. We have to use the difference quotient. To use the difference quotient, what do we need to find first? Yeah, we need to find f of x plus h. So anywhere we see an x, we replace it with x plus h. Like that. Put down our formula. And plug in what we know so far. So f of x plus h is this whole thing right here. 2x plus h squared minus x plus h minus 3 minus the f of x, which is 2x squared minus x minus 3 all over h. This one's going to get a lot longer before it gets any easier. Because what do we have to do first? Now, inside the first parenthesis, we have to do inside there. What can we do inside there? Well, here's an exponent. We have to do that first. So what we have here, we have x plus h squared, which means x plus h, x plus h. So we gotta distribute, we gotta FOIL these two. X times x is x squared. They're all positive, so I'm going with signs. X times h is xh. That one's finished. Now the h. X times h is xh. Then h times h is h squared. Combine like terms. X plus xh plus xh is 2xh. So that's what that part becomes. So that goes in place of the x plus h. So it's x squared plus 2xh plus h squared minus x plus h minus 3 minus 2x squared minus x minus 3 all over h. Looking at the first parenthesis in this one. Well, this first parenthesis. Can we do anything inside here? Can we do anything inside here? So we have to get rid of them. So distribute. We have 2x squared. 2 times 2 is 4xh plus 2h squared. And we'll get rid of the next one, the negatives. Negative x minus h. And then the minus 3. I just did everything inside the first big parenthesis. Do we need the first parenthesis? No, because there's nothing in front. Or can we combine any like terms? Are there any x squares in the first one? No. So we can't combine anything, so we can drop the parenthesis. And distribute the negative sign in the second one. So we have negative 2x squared, positive x, positive 3. Remember I said everything after this minus sign, everything over here after we get rid of the parentheses has to disappear. So combine like terms. The negative 2x squared cancels the 2x squared. The positive x cancels with the negative x. Positive 3 with the negative 3. You see how careful you have to be when you write all this stuff out.
my brain wants to like skip the step of writing out without the parentheses. It just feels redundant, but I see why it's so important.
Yeah, it keeps everything. You can eventually feel comfortable and confident. You can skip a couple of steps, but be very careful what you do that because you can't backtrack. This way, I can go back each step and see what I did. So what can I do now? Do they have anything in common? They each have an H on top. I can take out the H. I can take out one H because there are two H's in the middle. Now the H's can cancel. So my slope equation is that. But as H goes to 0, remember the distance between the 2 points? As H goes to 0, that disappears. So my equation of the line tangent, the slope of my equation line is that. So this defines the slope at any point of my curve. Pretty cool? Yes. Can we find the vertex of our curve? Remember, this is quadratic, so it looks like this. Can we find that point? What would be 0? You're right. The slope at the vertex is 0. So what is the x value at that point? Well, let's go back here. If the slope is 0, it happens where? Solve for x. Add 1 to both sides. So the slope, the vertex occurs at x equals 1/4. What's the y value at that point? And I plug that back in the original equation. That gives me the y value at that point. Then I have the actual location of the vertex. So you see, we have to always remember what we did in the past as well. All right, that does it for that section. Any questions? Remember, section 3, let me go ahead.